everyone, I am Dr. R. Soumya, Assistant Professor, Department of Electronics and Communication Engineering. Today we can see the subject sensors and actuators. Subject code is AU3008. Unit 4 is automotive actuators. Here we are going to see the topic single phase alternating current machines. Single phase AC machines are widely used in domestic and light industrial applications due to their simplicity and ease of operation. Unlike their three phase counterparts, they operate on a single phase AC power supply. Types of single phase AC machines. First one, single phase induction motor. Second one, single phase synchronous motors. In single phase induction motor, there are some classifications: shaded pole motors, split phase motors, capacitor start motor, capacitor start, capacitor run motor. Let us see the construction and working of single phase induction motor. Similar to a DC motor, single phase induction motor has basically two main parts. One is rotating and another one is the stationary. The stationary part in single phase induction motor is called stator, while the rotating part is called rotor. The stator has laminated construction made up of stampings. The stampings are slotted in on its periphery to carry the winding called stator winding or main winding. This is excited by a single phase AC supply. The laminated construction keeps iron losses to minimum. The stampings are made up of materials like silicon steel, which makes the hysteresis loss. The stator winding is wound on a certain definite number of poles, means when excited by a single phase AC supply, stator produces the magnetic field which creates the effect of certain definite number of poles. The number of poles of which stator winding is wound decided to synchronous speed of the motor. The synchronous speed is denoted as Ns, and it has a fixed relation with the supply frequency F and number of poles P. The relation is given by Ns equal to 120 F by P RPM. Here F is the supply frequency and P is the number of poles and Ns is the speed. The induction motor never rotates with the synchronous speed, but rotates at the speed which is slightly less than the synchronous speed. In the single phase induction motor, single phase AC supply is given to the stator winding. The stator winding carries the alternating current which produces the flux, which is also alternating in nature. This flux is called main flux. This flux links with the rotor conductors, and due to the transformer action, EMF gets induced in the rotor. The induced EMF drives current through the rotor at the rotor circuit is closed circuit. This rotor current produces another flux called rotor flux required for the motoring action. Thus secondary flux is produced according to the induction principle due to the induced EMF. Hence the motor is called induction motor. As against this, the DC motor, a separate supply is required to armature to produce the armature flux. This is the important difference between the DC and the induction motor. So the main winding, this is the primary winding of the motor connected directly to the power supply. It carries the main current required for the motor operation. Next one is the auxiliary winding. This winding is used for starting the motor. It is connected to series with a capacitor, which creates a phase shift in the current flowing through the auxiliary winding. Next one is the capacitor. The capacitor is a key component for starting the motor. Magnetic field essential for starting the motor. Centrifugal switch. This switch is mechanically connected to the motor shaft. When the motor reaches the certain speed, the centrifugal switch force causes the switch to open. Rotor. The rotor is a rotating part of the motor. It is made of laminated iron core which with a slot that carry the rotor conductors. The rotating magnetic field produced by the stator winding induces current in the rotor conductors, which in turn produce the magnetic field. The interaction between the stator and rotor magnetic field causes the rotor to rotate. Working while starting, when the motor is initially connected to the power supply, the capacitor creates a phase shift in the current flowing through the auxiliary winding. This creates a rotating magnetic field which induces the current in the rotor conductors. This current produces the magnetic field in the rotor, which interact with the stator magnetic field, causing the rotor to start rotating. Running, as a motor accelerates, the centrifugal switch open, disconnecting the auxiliary winding and capacitor from the circuit. The motor continues to run on the main winding core alone. Applications: it is mainly used in the household applications, commercial applications, industrial tools, agriculture applications, toys and hair dryers, and vending machines. So, duty type rating for electrical machines. So, what is duty cycle for a motor? The International Electrotechnical Commission defines the 8 classifications for duty cycle, grouped by the continuous, short term or periodic cycles. Duty cycles encompass the frequency and the duration of the typical operation, this including starting running with no or full load, electric braking and resting. Duty type rating for electrical machines define the specific operational cycle, including load, speed and rest period, that a machine can endure without exceeding its thermal limits. This rating is crucial for selecting the right machines for particular applications, as it ensures optimal performance and longevity.